All right, moving on to question 11. We're looking at graphs of P and Q that are given by these piecewise functions and a graph depicting them. So the first thing we're asked about is basically to determine where these functions fail to be differentiable. So let's think about what differentiable means. So if we have differentiability, so in very basic terms, that means if your function is differentiable at a point, then that means a derivative exists. So what is the derivative? The derivative is this limit. The limit as h approaches 0 of f of x plus h minus f of x all over h. So where does this limit exist? This limit is going to exist basically anywhere where I can, if we're looking at a graph, let's think about it in those terms. It's going to exist wherever I can think about, what the slope of a tangent line or what the slope of the graph is at a point. And in this case, that's going to be wherever, these graphs are made up entirely of straight line segments. So basically, it's going to be these functions are going to be differentiable, you know, on the interior of those line segments. So when I say interior, I mean it's not going to be differentiable at the end. Like for example, I could draw a tangent line at this point or at this function at this point like that, but I could also do it, I believe, like that. I believe you could also, like, I think you could say that both of those red lines I just drew touch that curve at that hard corner exactly once. So even though they're tangent, it's not unique, so I don't believe I could say they're differentiable there. So using that standard, actually, one thing I should bring up here is that one thing we've mentioned in the previous module is that if your function is not continuous, it cannot be differentiable. If you want to go back and revisit the definition of continuity, what those conditions are to have continuity of a function at a point, you can go look at it, but I will say that these functions that work everywhere there's graph here, I have continuity. So we can avoid looking at that, but where is P not differentiable? So P is not differentiable at wherever those hard corners are going to be. So P is not differentiable at x equals what? So P is the blue graph. And one of the points I picked is where is the, I think, the leftmost point where it's not differentiable. That's x equals -1. You're also going to have the same phenomenon at x equals 1. And I believe that's the complete list for P. So where is that true for Q? So Q is not differentiable at where? X equals, looks like also -1 and also 1. Okay, just gonna double check, but it looks like they are exactly, they're not differentiable exactly 2 points and they share those two x values, both -1 and 1. All right, so what about B? Okay, so now we have this new function R that we're using, that we're making out of a combination of P and Q. So where is R going to fail to be differentiable? So that's going to depend on where P and Q fail to be differentiable. So since R is a sum of some kind of combination of P and Q, then for R to be differentiable, I need P and Q both to be differentiable. So if only one of them fails to be differentiable, then R also fails to be differentiable. If we go back and revisit the points we found, there are no points where exactly one of these functions, P or Q, is not differentiable. They're both not differentiable at the same points, which means R is going to be not differentiable at these points as well. All right, moving on to part C. Determine R of -2, or R prime of -2 and R prime of 0. So let's remind ourselves what R is equal to. R of x is equal to P of x plus 2 times Q of x. So P of x plus 2 Q of x. If that's what R is equal to, Then let's get r prime of x. R prime of x would be equal to p prime of x plus 2 times q prime of x. So this is general. Basically, this will hold true for any x where the function is differentiable. So now, what is p prime of -2? P prime of -2 will be equal to, I'm sorry, r prime of -2. R prime of -2 will be equal to p prime of -2 plus 2q prime of -2. So now I need to find these individual derivatives. So what is p prime of -2? So p is the blue curve. I have a straight line segment. So to find p prime of -2, I can analyze the slope of p, anywhere to the left of x equals -1. So if I find a couple of lattice points here, it looks like this graph, for every 1 unit I travel to the right, the graph travels downward 2 units. So I believe that gives me a slope of -2. And what about Q? If I find a lattice point, so here's one, here's another. I believe if I use those 2 lattice points, then for every 1 unit I travel to the right, I am traveling upward by 3 units. I believe the derivative of Q at -2 is +3. So all told, this derivative will be -2 plus 6, which is 4. Right, so we can do a similar analysis at 0. So what is r prime of 0? That's equal to p prime of 0 plus 2q prime of 0. P prime of 0. So basically I'm looking as it crosses the y-axis. I see lattice points here and here. So the change in x here is 4 units. The change in y is 2. So I believe this is a slope of 1/2. And then what is the slope of q, the green function? So I have a horizontal line segment here. That tells me that my derivative is 0. So I get 1/2 plus 2 times 0, final derivative of 1/2. All right, moving on to part D. Find an equation for the tangent line at the point 2r of 2. Okay, so again, let's remind ourselves what r of x is. R of x equals what? P plus 2q. All right, P of x plus 2q of x. So let's stick with slope-intercept form. In the previous question, I did both slope-intercept and point-slope form. I'm not trying to show preference for one or the other. I'm just picking one this time, but I have no preference over which one you use. So let's get all this information. So I need to know, so I know that my x value, where this line is going to, for this tangent line is going to be, is 2. The y value that goes with it is, I'm not sure yet, so I think we need to find that. What is r of 2? R of 2 equals p of 2 plus 2 times q of 2. What is p of 2? P of 2, that's the blue curve. So when x equals 2, I think I also have y equals 2 plus 2 times q of 2. So on the green curve, where x is 2, the green curve has a y value of 1. So I think my corresponding y value from the function r is 4. So 4 equals m times 2 plus b. What is going to give us the slope? So the slope is going to come from r prime of 2. Is this from the values I just found? No. So we've got to go through this again. What is r prime of 2? That's going to be equal to p prime of 2 plus 2 times q prime of 2. And now we're looking at the slopes of lines again. What is p prime of 2? Let's find some lattice points. Looks like that slope is 2. And what is q prime of 2? That looks like -1. So I get 2 minus 2, that's 0. Okay, so that's going to simplify our calculations a lot here. So I basically have a horizontal line. So what's that horizontal line going to be? Well, essentially what we're going to have is this. 4 equals 0 plus b. So b is equal to 4. My tangent line is a horizontal line at y equals 4.